Okay, so lecture stuff for today. These are the topics we're going to cover. The statistical analysis for Lab 4. I will give you information about what you're going to be doing for Lab 4 Part 2. You should have already turned in Lab 4 Part 1, which is basically where you just compile the averages for the different conditions of our experiment, which I'll tell you more about, like kind of the theoretical background for the experiment today. We took the implicit association test, is what we took, the race implicit association test. And we included as a factor the order in which you go through the two primary conditions of the implicit association test. So we'll definitely talk about the way you're going to analyze the data for Lab 4 in just a second. And we'll also talk about this difference between explicit and implicit cognition. And I want to point out here that this is the difference between these two aspects of cognition is something that we actually talked about for Lab 3 for last week's stuff when we were dealing with musical expectations. This is a theme in a lot of research in cognitive neuroscience in general, this distinction between explicit and implicit methods. We have this distinction in the music perception literature, and this distinction is also very relevant, perhaps even more relevant on the literature about racial bias. Just so we're clear, explicit racial bias would you openly admit that you think one group is superior, one race is superior to another, you say you like one race more than the other. That's very explicit racial bias. Implicit racial bias, on the other hand, can occur even when an individual does not believe that they possess some type of racial bias. Implicit racial bias can be shown by looking at subtleties of an individual's behavior. So this is in the normal version of this class where we're doing physiological recordings. One of the main perks of physiological recordings is that they can measure things about a person's mind that person might not be consciously aware of, that is implicit things. So typically when an individual is asked, a lot of individuals, when they're asked questions about race, are you colorblind? Do you see a difference between black and white faces? Or do you feel you're racist? Most people will say, no, I'm colorblind. I don't view a distinction between black and white faces. But then you can use a physiological measure like EEG, which measures brain activity. And this person who says, no, I view black and white faces the same, I don't see a difference at all. But then you can look at the electrical activity in the brain when a person's looking at a black face, and when a person is looking at electrical activity in the brain when a person is looking at a white face. And you can see that in some individuals' brain, the electrical activity in the brain is different depending on whether a person is looking at a black face or a white face. And this is one of, I would say, at least in my opinion, the primary reason why physiological measures like EEG are good is because they can tap in quite effectively into these implicit processes. A person might not be aware of racial biases that they possess, but physiological measures like EEG are able to see the differences that we process people of different races, even if we're not aware that we are distinguishing between the faces of people of different races. So unfortunately, because of the COVID-19, we're not able to do EEG studies in this class, but we've been focusing on reaction time in this class. And part of the reason I've been focusing on reaction time is because it's kind of a physiological measure, but the thing that reaction time does very well, just like EEG and just like heart rate, which is another physiological measure, is that it can tap into implicit processes. People might explicitly say, no, I don't feel this way. But then you look at their subtle patterns of their behavior in terms of the reaction time. People oftentimes will differ in the way that they respond to a black face or a white face in terms of the amount of time it takes their mind and their finger to respond to a face and to press a button on a keyboard. And so this is the real power, at least in my opinion, on reaction time studies. They can tap into implicit processes just like other physiological methods like EEG or heart rate or blood pressure, just like those do. And then we'll talk finally about reaction time 1, which is a good example of implicit racial bias. So we'll really have two examples that we'll talk about today of implicit racial bias, the IAT, which is what Lab 4 was, and reaction time 1. Both are measures of implicit racial bias. So starting out with the analysis for Lab 4, and just kind of reviewing what the different factors were in that study. And I will show you how to run this analysis at the end of class. The analysis is a 2x2 mixed design ANOVA. So we have factor 1, which has 2 levels, and that factor is compatibility. And the 2 levels of this factor, there's 2 levels because that's the number 2, are compatible versus incompatible. And so some explanation for what these terms mean and why they're used this way. These are compatible and incompatible with the assumed racial stereotypes that exist in a given society. So if you assume in our society that there is racial bias against a group, against Black individuals to be specific, then compatible with the stereotype would be the idea that white faces are paired with good words and Black faces are paired with bad words. That's compatible with the supposed stereotype that exists in our society. Incompatible is incompatible with the stereotypes that presumably exist in our society. So this would be when a white face is paired with a bad word and when a Black face is paired with a good word. So that's where these terms come from. Compatibility, I want you to be very clear, compatibility with the stereotype which is presumed to exist in a given society. And so we manipulated that, like that's the very basic factor that exists in basically every implicit association test that's ever been run, and there's been a lot of them. The 2 levels are compatible and incompatible, and I'll remind you of what you experienced, what you saw in Lab 4 here in a second. That factor was within subjects, meaning that every participant who took our study on Lab 4 study was exposed to both of these conditions. Half the trials, white faces were paired with good words, and in the other half of the trial, white faces were paired with bad words within subjects. The other factor, which also had 2 levels, was the order in which people experienced these 2 conditions. So some people saw the compatible condition first, while the other, so these were the people that were odd numbered participants. So if your participant ID was an odd number, then you took the compatible condition first. That means that when you started out the experiment, you always do a couple practice trials at the beginning, but then you did the first set of experimental trials were compatible, meaning that the white faces were paired with good words and the Black faces were paired with bad words, compatible with the stereotype. Then after 56 of those trials, you would do the incompatible. If you were in this group, the first 56 trials would be compatible, then the second 56 trials would be the incompatible condition. That was about half the class. The other half of the class, the people with even numbered participant IDs, they had the incompatible condition for the first 56 trials, and then they had the compatible condition for 56 trials after that. And so this is considered a factor. This is counterbalancing, a term you've probably seen in research methods. Hopefully you heard about it in research methods at least. And this is counterbalancing, the idea that when you have a within subject factor, sometimes you can see differences that are based on the order in which people progress through those different conditions. And so you want to see is, does the order in which people experience compatible and incompatible conditions, does that influence their performance? Does that influence their reaction times? And so we're including this as a factor. So I've already performed the statistical analysis, and I will show you at the end of class how I did that. But for now, I'm going to show you the means of our different conditions, and I'm going to show you the output of the statistical analysis for Lab 4, Part 2. You're going to have to replicate my statistical analysis regarding reaction times, and then you're also going to have to perform a statistical analysis for the amount of correct. We have 2 dependent variables for this study. We have 2 factors, but we also have 2 dependent variables. The 2 dependent variables are reaction time and amount correct. The dependent variable that I care about the most, because it's the one that's published on this topic by far the most, is reaction time. And so that's the one I'm going to focus on the most during class, is reaction time. But for the analysis that you do, you'll have to do reaction time as a dependent variable and a separate analysis for the amount correct. So here are the reaction time data for our class. You know, it might help actually. Hold on, let me skip ahead real quick. These are just so we're very clear. These are the 2 examples. This would be the supposed compatible condition, because good is paired with white and bad is paired with Black. And then you would see an object in the middle of the screen, either a word or a face. You'd see something in the middle of the screen, and your job is to push E if it belongs in the left categories, or I if it belongs in the right category. So for this answer, the correct answer would be I, and for this answer, the correct answer would be E, because that's the side where Black Americans on the right side here, Black Americans on the left side here. So here the correct answer would be I, here the correct answer would be E. This would be the supposed compatible condition. Half the participants saw things like this first, and then they saw things like this. The other half of us in class saw things like this first, and then you saw things like this second. So here are the means of our we have 4 conditions. It's a 2x2 design, and so we have 4 conditions, and none of them were actually significant. This is the first lab that we've done so far where the expected effect was not. We found the direction of the effect was there. Like I saw the things that we showed were in the expected direction, but they didn't reach significance. And I was actually surprised because we have a decent sample size of 26 people. 11 people took the compatible condition first, and 15 took the incompatible condition first. And you can see those right here. These are the 15 people. Their means, if you took the incompatible first, and then the 11 people that took the compatible first, you take their means for the compatible and incompatible conditions. Those are shown here. And so the primary effect that you see in the implicit association test is the reaction times tend to be quicker for the compatible condition and relatively slower for the incompatible condition. And we can see that that trend is there. Right here, for instance, the black bar is lower than the gray bar, but this difference was not statistically significant. It was close, it was marginal, as some people would say. The p-value was almost 0.05, but it was not below 0.05, which is a little bit surprising. I've done implicit association test experiments a lot in previous classes, not here at KU, at my previous job, and every single time when I done it in a lab activity, it had shown a significant difference. So you guys are the first people who did not show a significant implicit racial bias. Though the trend, but the expected direction of the effect was there. There's no difference there, no difference there. Overall, there was no difference in the reaction times of the compatible and incompatible conditions. Another thing to kind of take a little bit of a note on is, even though the interaction was not significant, the two-way interaction, you can see that the difference here, even though it's not significant, is a little bit bigger than the difference here. And my hypothesis would be that if we ran a very large sample size, what we would find, this would be my hypothesis, I could be wrong, is that we would find a significant difference between the compatible and incompatible conditions for those people that took the compatible condition first. But we would find no significant difference, or a very weak difference for people that took the incompatible condition first. But I think overall, one of the limitations of this study is that we kind of had a small sample size of only 26, and it would have been better. Not everyone in the class took it on time, unfortunately. So that would have helped things if we had a bigger sample size, but really we need like twice as many people, I think, to see the effects, the expected effects. So here is the output of I'll show you this in a second. This is a Google sheet that you're gonna need for Lab 4 Part 2. Maybe I can click on that real quick. Yeah, here we go. So here's all the data. So you guys originally copied and pasted your data into 2 different Google Sheets, but when you're running an SPS analysis in SPSS, everything has to appear on the same sheet. So I went ahead and moved all of the data from those 2 separate sheets. One, the compatible first, these are the odd numbered participant IDs. They're right here. So these are all the data from the odd numbered participants. These are the people that had the compatible condition first and the incompatible condition second. And then over here, all these are the data of people that took the incompatible condition first and then the compatible condition second. The first 2 columns are the reaction times. Column C and D are the amount of correct responses. There was one participant who forgot they included the amount of correct responses for the congruent condition, but they did not include the amount of correct responses for the incongruent condition. So I just erased I erased this number here. So for this participant, we just have missing data, and I said it right here. This participant omitted amount of correct for the incompatible condition. But when you're doing an ANOVA, you need to have data in both places, or else it will cause an error message. So I erased the one that they did include, and maybe that person who missed that could maybe include that for completion later, their value right there. There's other things that you can check out for your benefit below this. Right here, you can take a look. I basically used Excel to calculate the different means that are compared for the different analyses. And so you can take a look at those. Yeah, so let's go back here. So those are you'll need this to copy and paste into SPSS for when you're doing Lab 4 Part 2. You'll need those data. You'll have to do one analysis for the reaction time, and then you'll have to do another analysis for the amount correct. I went ahead and have done I've done the analysis for reaction time, and nothing was significant. When you have a factorial design with 2 factors, there's going to be 3 p-values, that is 3 F's, that are calculated by SPSS, and none of them were significant. The main effect of compatibility, which is the main thing, this is once again, is there a difference between the compatible and incompatible conditions? It was close to 0.05, but it wasn't quite there. My belief is that if we increase the sample size, this would get significant pretty fast. So I think we have an underpowered study, is my belief. There was also no main effective order. But the trend that was there was that people were slightly quicker overall in the compatible, and for those individual, the odd number of participants, people that took the compatible condition first and then the incompatible condition, overall, they were just quicker. The people that took the incompatible condition first and then the compatible condition, they were a little bit slower. But once again, this effect did not reach significance. And I'm not actually for sure that if we increase the sample size, whether this would ever be significant. Not for sure. And then finally, the compatibility by order interaction was not significant, though it was in the predicted direction. And so I want to explain a tiny bit more about what I was expecting regarding the compatibility by order interaction. So first off, the compatibility by order interaction, basically what it does is it calculates this difference right here between the compatible and incompatible conditions. And it also calculates this difference right here. And you can see this difference is kind of big, whereas this difference is quite small. And it's basically determining, is there a significant difference between these differences, which is one of the things that makes interactions complicated. Is there a significant difference between the differences? So there's a difference here of around 50 milliseconds, whereas there's a difference here of around 15 milliseconds. Is 50, which represents a difference, is that significantly different, significantly bigger than 15, which also represents a difference? So is this difference bigger or different than this difference right here? And the answer was no, it wasn't. I was expecting for it to be significant. Once again, I believe it's because our study was underpowered. The reason I was expecting it was because of previous research that's been performed on the implicit association test. It was not exactly like our study, but it was similar in some ways. So I was expecting it. I was expecting that interaction. So let me explain why. So first off, the study which started this all was Greenwald et al. 1998, published in Journal of Experimental Psychology. And it's been cited a lot, 13,000 times. I do not know of an article in psychology which has been cited even close to this many times. This is like a classic study if there ever was one. I do not believe I've ever seen a study which has been cited more than this, or even close to this many times. So Greenwald et al., which is what I'm going to talk. I didn't have you guys read it because it's kind of a long and complicated study. So what I'm going to do, instead of having you guys having to find the important stuff, I'm just going to take kind of the important stuff out of the study, and I'm going to present it in lecture today, including why I expected that statistical interaction that we didn't find. So the Greenwald study contained several experiments, all using the implicit association test, though only one of the experiments in Greenwald et al. 1998 actually concerned race. the primary studies, the ones that were presented early in the paper, was actually looking at implicit, I guess you could call it bias, but yeah, we could call implicit bias for flowers and insects. And so the conditions were kind of analogous to what we were dealing with race, but instead of people seeing white faces and black faces, they were seeing pictures of flowers and pictures of insects. And sometimes those flowers were on the same side as pleasant, in which case the insects would be paired with on the same side of the screen as unpleasant. That would be the compatible condition. And then sometimes there's the incompatible condition where flowers were paired on one side of the screen with unpleasant, and insects were paired with pleasant. That would be the incompatible. So the idea here is that the stereotype, if you want to call it, or the assumption is that flowers are considered something which are pleasant, and insects are considered something which are unpleasant. And they wanted to see, do people's reaction times, do they reflect this bias or this kind of belief, the stereotype that flowers are considered pleasant, whereas insects are unpleasant. And they did find that. So this is not racial at all, but they did find reaction times were faster for the compatible condition compared to the incompatible condition. That is, when people would see a flower or an insect in the middle of the screen, or they would see a word like happy, or they would see a word like misery. You know, that happy would be a pleasant word, misery would be an unpleasant word, and you have to categorize it. Does that object or word, does it belong on the left side of the screen or the right side of the screen? People were faster to make those classification judgments in the compatible condition compared to the incompatible condition. So, and it was a strong effect. It was a sample size of 32, which was not dramatically larger than ours. They found a really significant effect where the p-value was way less than 0.05. Whoops. And most importantly, and I'll show you, I think I have the data for this, yeah, right here. Most importantly, dealing with this interaction, the reason why I expected us to find an interaction, they found larger compatibility effect when compatible first condition for people that saw the compatible condition first compared to people that saw the incompatible condition first. So this is a lot of words. It's hard for my brain to even keep straight when I'm just looking at it right here. So I just want to go ahead and show you the data. And I've kind of repeated the same words again. I wrote them two different ways. The interaction, they found a significant interaction, which showed that the compatibility effect was smaller when the incompatible trials were first. And analogously, the compatibility effect was larger when the compatible trials were first. So let's take a look at the data. These are confusing graphs a little bit, so I'm going to have to kind of walk us through them. The two things that we are most interested in are the black bar and the white bar. And all you really care about is the left side of the graphs. The right side of the graphs is relevant, but for our purposes, really you should just ignore the right side of the graphs. Really, I just don't even look at them. They show the exact same pattern, and they make the graphs needlessly complicated, in my opinion. So just ignore the right side. All you want to do is look at the left side of these graphs. What we care about is the black bar and the white bar. And then over here, it's the white bar, then the black bar. So the black bar is the non-compatible condition. So this is when flowers were paired with unpleasant words first. That's the non-compatible condition. And they're looking at latencies, reaction times right here. And what they're showing here is that compared to the non-compatible compared to the compatible condition, people are showing bias, evidence of bias against the insects. They such that the reaction times are longer in the non-compatible condition compared to the compatible condition. So this is, the expected effect. They showed patterns of bias. When the labels were switched, they were incompatible with the stereotype that flowers are pleasant and insects are unpleasant. That resulted in people taking longer to make those classification judgments. It was harder for them. And what I want to point out, though, is this is the incompatible condition first. And they look, this is very helpful. This little thing right here, totally very helpful. This is the compatibility effect right here. the compatibility effect is the difference in reaction time between the incompatible and compatible trials. I will come back to this. I've been already doing that. When I'm doing this little thing right here, that's the compatibility effect right there. That's the difference between the compatible and incompatible trials. Same thing here. That's the difference between the compatible and incompatible trials when we're comparing the height of the black and gray bar there and the height of the black and gray bar there. So the one thing that I really do like about these graphs is they show, and they're very specific, the difference in height between the black, the non-compatible, and the white bars for this was 145 milliseconds. And it's very important that you also notice here, the incompatible condition was first and the compatible condition came second. And there was a difference in reaction times of 145 milliseconds. Down here, this is when people saw the compatible condition first, and then they saw the incompatible condition second. And you can tell it's different because here the black bar occurs earlier than the white bar, occurs to the left of the white bar, but here the white bar occurs to the left of the black bar. And then once again, they're showing you the compatibility effect, or what they're calling the IAT effect here, which is the difference between the black bar and white bar. The difference in reaction times between these two bars was a difference of 234 milliseconds. So once again, that interaction, it's called the compatibility by order interaction. What that's comparing is this difference, this 145, this is a difference between the black and white bars. It's taking that difference and this difference right here, which is 234, and it's saying, are these differences significantly different from each other? And the answer was yes. This number of 234 milliseconds was significantly bigger than this number, 145 milliseconds. So in other words, people showed more evidence of bias against the insects when the incompatible condition was second and the compatible condition was first. When the incompatible condition was first and the compatible condition was second, there was still evidence of bias against insects in a pro-flower stereotype, but the effect was muted. It was smaller here, only 145 milliseconds, whereas here it was considerably bigger, 234 milliseconds. So here's the explanation that I've summarized from the article. I'm not going to just read this here, but this is pretty important to understand the motivation for why I expected to basically find the analogous thing for us. That we would find more evidence of racial stereotype for people who saw the compatible condition first and then saw the incompatible condition second. I expected us to replicate this finding where we would find bigger differences here for when the compatible was first, incompatible second, compared to when the incompatible was first and compatible was second. Once again, it wasn't significant, but it was in the same direction. If you look, this was a difference of around 50 milliseconds. So although it wasn't a significant difference, the difference here was 50. The difference here was 15. So it didn't reach significance, but it was in the exact same as in the expected direction. A really interesting question, one that I'm now actually thinking of seriously, writing an IRB up and actually doing it as a study and maybe trying to get it published, would be if we increase the sample size dramatically, would we find the interaction? For the flowers insects difference, they found this in the interaction. But it's unclear to me whether if we increase the sample size for the racial one, whether we would find the significant difference. Okay, so here's kind of a couple more things on this, and then I'm almost done. So I've already mentioned, we did not show a significant main effect of compatibility, although the expected direction was there. In general, people were a little bit quicker from compatible conditions than the incompatible conditions, although it wasn't a significant difference. We also didn't see that interaction is in the expected direction once again. In the compatible first condition, there was a difference of around 50 milliseconds between compatible and incompatible conditions. For the incompatible first condition, the difference is only around 15 milliseconds. And those differences were not significantly different for us. One possibility is that our sample size might have just been too small. We only had a sample size of 26. Or it might just be the case that order effects might not exist for racial bias, which is an interesting theoretical question. Clearly, order effects did exist in the study I just talked about, the Greenwald 98, for the flower insect example. the order effects definitely did exist. There was a significant interaction. However, in Greenwald et al. 1998, they did one race study, and they did include order, the order as a factor, where so half the participants were in the compatibility first condition, the other people were in the incompatible first condition. And they did not show that interaction either. So this is interesting. For the flower insect study, they did show that compatibility by order interaction. But for the race study that they did, even though it was very similar structurally, it's just with faces instead of flowers and insects, they did not show that interaction. So it's actually quite unclear what would happen if we did a study with a large sample size. It's possible that we would show the interaction like they did for the flower and insect study, or it's possibility that we would not show the interaction and replicate what they found in their race study. And the reason I'm going into such a big explanation of this is because after doing this lab, and then yesterday I actually spent a couple hours doing some research, to me, I don't actually believe there's ever been a study done where they've done a large sample size study looking at order effects for the racial bias IAT. And I posted on Facebook in a group with 40,000 psych professors on it and graduate students. And I asked, has this ever been published where they've done a large sample size study looking at order effects on the implicit association test for race? And there were not very many responses. And no one said affirmatively, yes, that this has been done before. And so I'm now beginning to think that this is actually a study which I could do and maybe get published, because it doesn't appear like anyone has actually answered this question with the sample size which is sufficiently powered to do it. So it's another thing for me to add to my to-do list. It's actually really interesting research. So the way I proceed is making sure that no one has done this before, where they've done a large sample size study looking at order effects for the race IT. And then assuming that no one has done that before, doing a large sample size study, just like what we did for this lab, and seeing if that statistical interaction becomes significant when we have a large enough sample size. And either way, the result, whether it became significant or not, would be interesting, just because based on the current literature, it's not actually clear what would happen. Okay. Implicit versus explicit bias. These are terms that I was talking about at the beginning of class today. Implicit bias is something that the IAT, which is in the name, is supposedly measuring implicit bias. And it's bias that can exist even when a person's not aware. As I mentioned at the beginning of class, most people will say, if you ask them, do you hold racial bias? They'll say no. But then if you actually look at measures which are sensitive to implicit aspects of cognition, like electrophysiological measures, or maybe the rate of heartbeat or reaction time in the implicit association test, you can actually find that people will treat people of different races differently based on their reaction times, and their brain will respond differently to them, even if they say that they're colorblind, if they don't see the difference. So contrasting that with an explicit bias, which a person will openly admit, or they'll openly at least think to themselves that they're aware of a bias that they have, where they favor one group or one type of thing over another group or another type of thing. And it should be pretty clear by now that a person might have no explicit bias. So they might think that they don't think that they'll show differences in the way they treat different races. But if you actually look at the details, there's subtle differences in their behavior. They will show evidence of implicit bias. So this takes me to reaction time 1. So this is the article that you read for today. I believe you already took a quiz for it that was due earlier this afternoon. And it's another measure of implicit bias, but it's slightly different paradigm. So in each trial, so this is a review study that you read for today, but the main article this was a review, meaning they talked about several different aspects of this literature. But the study that is most relevant to us was a study that was presented relatively early on. It was kind of like the highlighted study at the beginning of the review article that you read for today, in which a prime was presented. So a prime is usually something that appears on a screen, like a picture, and it occurs really quickly. And the purpose of that prime is to kind of influence cognitive processing, mental processing. So in this study, the prime was either a white face or a black face. So on a computer screen, a white face would appear really quickly. or a black face would appear really quickly, and that was the prime. So you're either primed with white face on a given trial or a black face on a given trial. Then an object would appear in the same on the middle of the screen after the prime. So after the face that you just saw, an object would appear. That object would be a gun or a tool. And the participant's task was to report, what did you see, a gun or a tool? And participants were faster to report that they saw a gun when the prime was a black face compared to a white face. So I'll just say that again. When the prime was a black face and then a gun appeared, people were able to answer, it's a gun, more quickly than when a white face appeared and then a gun appeared, in which case they were a little bit slower to say it's a gun. And I don't want to spell this out too clear, because next class, my plan is to have an in-class discussion activity where I basically am asking you, take this finding and kind of connect it to, you know, the events that have been happening recently in the United States of America. You know, connect, you know, how could this help to explain some of the events that we've seen regarding police shootings in this country. So that's not going to be today. That'll be next time, because we have another reading which is related to this. But that's kind of where I'm getting at, is these types of findings, in theory, can explain some of the police shootings, the tendency for there to apparently be a racial bias in police shootings. Okay. So I think that's it for today. Yeah. Okay. So right here is a link to a YouTube video where I show you how to do the Lab 4 analysis for reaction times. So Lab 4 Part 2, you need to run, this is what I show you, the 2x2 mixed ANOVA for reaction times. And you have to have at least 26 people. That's what, like right now, there's 26 people on that Google sheet. At least there was when I checked it earlier today. People might add their data late. Actually, I don't think they will be adding their data late to this Google sheet. So most everyone will probably be running the analysis with these 26 participants. Though if someone adds data later, it's possible that someone could be running the ANOVA with more than 26 participants. I don't think that's going to happen though. So you have to run the ANOVA with at least 26 people for reaction times. And basically what I want you to do is duplicate those F values and P values that I showed you earlier in the class. Basically, I want you to duplicate that. And I show you step by step how to do it right here in this link. I also want you to do the same thing for the amount of correct responses. So I don't show you step by step how to do it for amount of correct responses, but it's completely analogous. So if you're able to understand what I did here for reaction times, then you should also be able to kind of apply that and do the same analysis for correct responses. This is probably a type of ANOVA you've never done. I doubt you've done a mixed design ANOVA before. Mixed design is an appropriate analysis here because we have one within subjects factor, compatibility, and we have one between subjects factor, order. And so we have mixed design because we have one between and one within subjects factor. For Lab 4 analysis, what I want you to do is record your analyses, both of them, in SPSS using Zoom. Just like you've done for different assignments, create a link. So save it to some cloud service like Google Drive or Dropbox. Save it there, create a shareable link, copy and paste that link into Microsoft Word document, and submit that Word to Blackboard. The submit icon is already there. I believe I'm making this due Friday. Usually the lab part 2s are due on Friday, and that's when I've made this one due. So it's due at the end of the week, so you do have some time to work on it. So that's it for things. So I'm going to stop recording now.